Good afternoon, everyone. Let's just begin our problem solving session. I'll share my screen. Is my screen visible to you all?
Yes.
Okay, good. Very good. So, we are in the week 5 of our problem solving session, and today we will be discussing about week 5 content, which is about basics of mass spectrometry. So I have accommodated few questions, multiple choice questions, and we will discuss that as we are discussing for our earlier session. So this is the first question of mass spectrometry based assignment. So, which of the following is true for mass spectrometry? Mass spectrometry offers molecular specificity. The ion optics of mass spectrometer allows for the proper ionization of the compounds. Sensitivity of a mass spectrometer decreases with increase of the mass of the compounds. And option D, positive, negative, and neutral ions are produced by the ion source and all are readily detected by the detector. So, any guesses? If you have gone through the lectures of week 5, you will be able to figure out the true options among the four.
A and C, I think are correct.
C and which one?
A and C. A and C.
A and C. Yes, you are very correct. A, mass spectrometry offers molecular specificity, and second, sensitivity of mass spectrometer decreases with increase of the mass of the compound. Okay, so as the mass of the compound increases, the sensitivity of the mass spectrometer decreases. So going to question 2. In regard to matrix used in any chromatographic technique, which of the following is not an important characteristic to be considered? So generally for proteomics study, before going for your mass spectrometry analysis, chromatographic technique is used. So here are various characteristics given for any chromatographic, and you have to select which of the following is not an important characteristic. So option A is charge on the matrix, B form of the matrix, B shape or size, C porosity, and D method of preparation of the matrix. What is the correct option? See, option A will just figure out from going through all the options. So, charge on the matrix. So, charge on the matrix, it will definitely play a role in binding the molecule of your interest. So, if it has a, let's say, if your matrix is a negatively charged and your compound of interest or your protein is positively charged, and if you are interested to isolate positively charged peptides or some protein, then you will use a negatively charged matrix. So, a charge on the matrix is an important characteristic. It plays a role in separation of your proteins. Then second is the form of the matrix, which means its bead shape or size. So size is also a very important characteristic because so uh, depending upon what is the bead shape or size, uh, it will it will let the compound of your interest whether pass through the I mean it will pass through the matrix or it will interact with the matrix. So if the bead shape is very bigger and the void volume is less or vice versa, so it will affect how protein or how the compounds present in your sample will interact with the chromatographic matrix. So bead shape or size also play an important role. Porosity. So definitely this will also play a role whenever you are separating any protein or compound of your interest. So how porous is your matrix, or that will also I mean if your matrix is highly porous, then more number of molecules or more number of compounds can pass through it, so and vice versa. So even porosity plays a role whenever you are performing chromatographic technique for your protein sample analysis. And option D is method of preparation of the matrix. So a method of preparation of the matrix. So this does not have any role with how a protein or a compound of interest will interact with a chromatographic matrix. So the correct option is option D, method of preparation of the matrix. Okay, so all these three change on charge on the matrix, form of the matrix, and porosity. These are an important characteristic of a chromatographic technique. So whenever you are uh, whenever you are planning an experiment, let's say you want to um, uh, suppose you are interested in protein X and it has some charge, and you know that its molecular weight is that. So taking that information into account, also what kind of your sample is, whether it is polar, non-polar, and depending upon that you can select your chromatographic technique. uh, so all these things are important whenever you are selecting chromatographic technique for your experiment. So coming to another question, Rekha wants to perform an LCMS experiment. The instrument setup has an electron spray ionization source. Which of the following points should she keep in mind while preparing the sample of analysis? So electron spray ionization, it's a soft ionization technique. So as you know that in mass spectrometry, the basic principle how a mass spectrometry works is that it separates your compound of interest based upon its mass to charge ratio. Okay. So, generally, different ionization techniques like chemical ionization, electron spray ionization, then various hard ionization techniques are also used for the fragmentation of your, um, sorry, for providing the charge to your compounds. So, in case of electron spray ionization, this is the ionization source. It provides the charge to the compounds of your interest. It's a soft ionization technique, which means that your compound will not be directly fragmented. Okay, so it will retain its molecular form. So let's say your compound is of uh, 150 kilodalton. So 150, so it will retain, so it will, depending upon the ionization mode, whether it is a positive or negative mode. So plus H or minus H, it will generate, and a charged species will be generated. However, it will not lead to fragmentation of your molecule. So whenever you are using electron spray ionization source, so which of the following points should she keep in mind while preparing the sample for analysis? So option A, the sample should be mixed with a suitable matrix for proper ionization. Option B, the sample should be in a solution. Option C, the buffer used to prepare the sample should be compatible for mass spectrometry. And option D, the sample should consist of only small molecules. So which of the following is the correct option in when you want to use LCMS, uh, when you are using ESI as a ionization method?
I think B.
With B, the sample should be used. The sample should be in a solution.
Yes.
Yes, so that is correct. The sample should be in a solution whenever you are using electron spray ionization technique. Okay, and there is also another important another option. The buffer used to prepare the sample should be compatible for the mass spectrometry. So you should also take this into account, that you are uh, uh, whenever you are preparing your samples, so generally whenever uh, uh, you are reconstituting your sample in some kind of buffer, okay, before injecting it into your mass spectrometry. So the buffer which you are using, it should be compatible to the mass spectrometry. Otherwise it will create, I mean, it could create lot of problem with mass spectrometry. So, buffer you use for the preparation, that should also be compatible. So you should see, because there are certain buffers and certain chemicals which might generate a very high response, and the compound of your interest, it could hamper, it could it could hamper its detection. And there is also another concept of matrix effect when you are using mass spectrometry. So that is why you should always check which buffer you are using, whether it is compatible to the mass spec or not. So option, coming to another question, in proteomics, why chromatography is needed before mass spectrometry? So, as I mentioned earlier, also generally chromatography is performed before going for mass spec analysis whenever you are doing proteomic studies. So, what is the role of that? So, option one, to remove impurities from the sample. Option, okay, just a minute. I have to let someone in. The screen is visible to you all?
Yes.
Okay. Okay, so we were discussing that what is the role of chromatography uh, before the mass spec. Why are we using chromatography in proteomic study? So option A is to remove impurities from the sample. Option B, to reduce the complexity of the protein sample. Option C, to increase the concentration of sample to be injected into the MS, and to break down the proteins into short peptides.
I think A and C are correct.
A and C, to
Yes.
remove impurities from the sample, to increase the concentration of the sample to be injected into the MS.
Yes.
How will you increase the concentration of the sample?
I think for HPLC, I think it stays somewhere and then it does concentrate the sample. Specifically for HPLC.
Generally, we use chromatography to separate the protein of our interest, right? Based upon its molecular weight or charge or something like. So, generally, to reduce the complexity of the protein sample, we are using chromatographic technique. So, to increase the concentration of the sample, first of all, why you need to increase the concentration before injecting in the MS? So you should also see. I mean, by concentration. If you inject very high concentration, mass spec is anyway very sensitive instrument. So it can even detect at femto or picomolar levels. So uh, generally, at low concentration, only the samples are injected in mass spec. So, the one of the major reason of using chromatography is you are interested in particular set of proteins in your sample, but your protein sample will have lots of other things. Okay, so to remove the impurities or other proteins from your sample, you use a chromatographic method. And definitely, it does not break down proteins into short peptides. You need some protease or something, or some chemical denaturing methods to break the proteins. The chromatographic method does not help in breaking down the proteins to short peptides. So, this option is completely incorrect. So, coming to another question. So, here Manish has two proteins, A and B, in a mixture. Okay. A is positively charged 150 kilodalton protein, and B is a 50 kilodalton negatively charged protein. He splits the sample into many aliquots and uses different chromatography techniques to separate the two. Pick the true statement. So here, Manish is having two proteins A and B, and he is interested in separating these two proteins because he has a mixture of A and B protein. So now you have been given two important information regarding what kind of proteins A and B are. One is protein A is positively charged. What is the charge? And another is the molecular weight. So protein A is positively charged 150 kilodalton and protein B is 50 kilodalton and it is negatively charged. So, depending upon the characteristic of your proteins, you have to see which kind of chromatographic method is suitable for this two proteins. So here in option A, in size exclusion chromatography, A will elute out first as compared to B because A cannot pass through the pores in the gel beads and hence travel through the interstitial space. Okay, so first is for size exclusion, and they are saying that A will elute out first compared to B. Now in option B, it is size exclusion chromatography, but here they are mentioning that B will elute out first compared to A because of the smaller size of B. So that will travel fast. And option C is anion exchange chromatography, where B will elute out first as opposite charge on the stationary phase will separate the positively charged peptide. And option D is cation exchange chromatography. A will get bound to the matrix and be eluted using buffers that suitably alter the pH.
Ma'am, A and D.
A and D.
B and C.
B and C. Okay. Any other options? Any other
C
consent?
only. C. C
A and
only.
C.
C and
C
D.
only. C only.
C and D. Okay, so we will see one by one all the options and then we will figure out which is the correct option. So coming to option A, in size exclusion chromatography, A will elute out first compared to B because A cannot pass through the pores in the gel beads and hence travel through the interstitial space. So in size exclusion chromatography, the separation is based upon the molecular weight. Now, generally, you will think that less or lower molecular weight will elute out first because uh, it's in low molecular weight, so it can travel faster. But it is reverse in case of size exclusion chromatography. Why? Because I will show you in the diagram. I think that diagram is misplaced. So, so just a minute. So just a minute, I'll share the screen again. I think one diagram I have kept and I could not find. So give me a minute. Okay. So unfortunately, I don't know that could not be saved, so I could not find that figure. So basically, in size exclusion chromatography, if the if your compound is very small, it will pass through the void. Okay, and sorry, it will interact with the beads of the size exclusion chromatography, and that is why it is retained on the chromatography. Whereas the bigger molecules, it it cannot interact with the beads, and that is why it will pass through the interstitial spaces, that is the void between the beads, gel beads, and that's why it will elute faster. So, in case of size exclusion chromatography, if we see the molecular weight of A is more than B, so 150 kilodalton is the molecular weight of A. So, that will elute out first as compared to B because as B is a smaller molecule, it can interact with the gel beads, whereas A being a bigger molecule, it will pass through the interstitial spaces. Okay, so this is the correct option. Now coming to option B, in size exclusion chromatography, B will elute out first as compared to A. because of the smaller size of B, hence travel fast. So as I mentioned and explained you, this is incorrect. In case of size exclusion chromatography, smaller size molecule will interact with the gel beads, and that is why they will be retained on the chromatography, whereas the bigger molecules, it will pass through the interstitial space, and that's why they will elute first. So this is wrong option. So in anion exchange chromatography, B will elute first as opposite charge on the stationary phase will separate the positively charged peptides. So in case of anion exchange chromatography, negatively charged compounds will be retained by the chromatography. Okay, so here what is written, B will elute out first. So B is negatively charged. Okay, so this is incorrect because B will interact with the uh, matrix of the chromatography, because this is anion exchange chromatography, and in that case the your chromatographic matrix will have a positively charged beads, and that will interact with your negatively charged protein B, and that is why it will be retained, and it will be retained, so it won't be elute first. So this option is incorrect. And coming to option D, in cation exchange chromatography, so here the same, the principle is similar to anion exchange. In case of cation exchange chromatography, positively charged proteins or peptides are retained. Okay, so your chromatographic matrix, it will be negatively charged, and that is why positively charged proteins will interact with your chromatography, and it will be retained, and that is why they will not elute early. So what here it is written, in cation exchange chromatography, A will get bound to the matrix, correct, because A is positively charged. So it will interact with the negatively charged matrix of the cation exchange chromatography and be eluted using buffers that suitably alter the pH. So to elute that particular protein of interest, after your separation is done, you have to pass certain different kinds of buffer, and that will alter the pH, and your bound protein will elute out after that. So option A and D are the correct option. So I hope this question is clear, because there were lots of confusion, and everyone were having different opinions. So if there is still any confusion in these two chromatography, you can ask. Okay, so I think there's no confusion. So I will move to the next question. So, Shikha has purified a protein from her bacterial cloning experiment. She ran the purified protein on the Maldi MS to get a mass spectrum. The mass spectrum looks like this. Okay, so this is the mass spectrum from the Maldi MS mass spectrum, and what can be concluded by looking at the spectrum. So, looking at the spectrum, say depending upon the option given. So option A, two peaks imply that the sample is contaminated with another protein. Smaller peak is of matrix used in Maldi. C, the protein is further fragmented into several peptides, and hence the smaller peak is seen. The bigger peak represents the protein in singly charged state, while the second peak is of less commonly doubly charged state. So which of the following is the correct option? Any guesses? So if you have gone through the lectures of Maldi, you will be able to answer this. It's simple. So the correct option is option D. The bigger peak represents the protein in singly charged state, while the second peak is of less commonly doubly charged state. So generally, in case of Maldi MS, your protein is singly charged, but many a times you will find a second peak which is of the doubly charged state. So the correct option is option D. So this all, so just going through other options, the two peaks imply that sample is contaminated. So this is incorrect. The small peak is of matrix used in Maldi. So no, it's not of Maldi. And each protein is further fragmented into several peptides and hence the smaller peak is seen. So that is incorrect. Um Each protein is further fragmented into several peptides. So if there are several peptides, it might have different molecular weight and you will not see just one peak. So this information is incorrect. So generally in case of MALDI, you will see second peak of doubly charged state. Okay. So coming to another question, what are the advantages of ESI over Maldi? Analysis of complex samples can be achieved using ESI coupled with LC. It can be used to analyze purified and undigested protein. It does not involve the use of matrix in sample preparation, hence avoiding matrix interference. It is more salt tolerant as compared to Maldi. So, what are the advantages of ESI compared to Maldi? So, in comparison to Maldi, what are the advantages of ESI?
Ma'am, A and C.
A and C. Analysis of complex samples can be achieved using ESI coupled with LC, correct. And option C, it does not involve the use of matrix in sample preparation, correct. You don't use matrix in case of ESI, whereas for Maldi, you need a matrix for sample preparation, hence avoiding matrix interference. So, seeing option B, it can be used to analyze purified and undigested protein. So, this is not true. You cannot generally, proteins are of a higher molecular weight, so you digest it first and then you perform MS. So this option is incorrect. It is more salt tolerant as compared to Maldi. So this is also incorrect. It is not more salt tolerant compared to Maldi.
Ma'am.
Huh? Yes.
Yeah, but I think in the notes that's given to us, I think it says that AC can analyze the higher molecular weight samples. So uh, I was confused with option B.
Okay, so it can analyze it. It is comparatively to Maldi, but it is not like you need to digest. If your molecular weight of a particular protein is a it's a very big molecule, then you need to digest it. Use and only then you can analyze. So there are few low molecular weight proteins also which you can. Which you can use, but for very high molecular weight you need to digest the protein. So it will be in comparison to Maldi. Yes, I can detect high molecular weight, but that is in comparison, not in general. I hope your doubt is clear. Otherwise, it will, I mean, you cannot directly inject any protein into mass spectrometry.
Okay. But of course, the matrix in the Mardi technique, the matrix is, I think, is not listed as an interfering factor in the Mardi. So
Okay,
uh, yeah, so I was getting confused because
okay.
the matrix in the Mardi is not listed as an interfering factor to start with. So I was
Mm-hmm.
confusing with that undigested protein because then that would be an example of a complex protein, which is listed as one of the advantages in AC.
Mm-hmm.
But I guess, yeah, but I think,
So yeah, you have to see, depending upon the protein of your interest, you can select whether you want to go ahead with ESI or MALDI. So of course there are pros and cons of both the techniques. So uh, which technique to use is, it is not that ESI is better than MALDI or MALDI is better than, it is based upon your I mean your protein, which and what kind of protein you want to analyze or separate, and depending upon that you have to see these different factors like advantages and disadvantages of all the different techniques, and then you can go ahead with your experiment. So coming to next question, Shapana is a cancer researcher and wants to do deep proteome-based shotgun analysis of one of her patient sample. Which of the following instrument would be most preferred for her experiment? Triple quadruple mass spectrometer, QTOF, MALDI-TOF, and Orbitrap fusion. So, which of the following mass spec will be a better instrument for Shapana's deep proteome study?
Is it orbital?
Yes, correct. It's Orbitrap. So, why Orbitrap? Any answer?
It is a tri-bit technology.
Sorry, I could not hear you.
It is a tri-bit technology. Hello.
I could not understand. So basically, the resolution of orbit wrap is the highest amongst all. Okay, so whenever you are performing deep proteome based analysis, so you need high resolution instruments for your experiment. So that is why orbit trap fusion will be the instrument of choice uh, whenever whenever you want to, or whenever anyone wants to do deep proteome based shotgun analysis. So, so this, I think we have covered all the questions which I have enlisted for today's session. So apart from this, if you have any query, we can discuss, or you, yes, you have any query, you can ask, we can discuss that, or we can end the session. I missed. So all the questions were clear to everyone?
Yes, ma'am.
Okay, nice, very good. So any other questions or doubt? Should I stop sharing?
Thank you, ma'am.
Thank you. So I'm ending the session, and we'll meet next week, Saturday, same time. So thank you everyone. So final exam is objective type. The information will be provided to you. You can contact other TA. I don't have any information regarding it.
Thank you, ma'am.
Thank you everyone. Have a
Thank you, ma'am.
thank you. Goodbye.